Hello everyone, welcome back to Physics online classes for class 12 students. Let us continue chapter 3 current electricity. Today we are going to study about NCERT numerical problems part 2. You can remember we already completed theory part regarding the chapter current electricity, and in the previous class we solved some NCERT numerical problems. Let us continue the remaining NCERT numerical problems. Yes, so we completed up to 3.6. That means we completed 6 NCERT numerical problems. So now let us solve 3.7. That is 7th problem. A silver wire has a resistance of 2.1 ohm at 27.5 degrees Celsius and a resistance of 2.7 ohm at 100 degrees Celsius. Determine the temperature coefficient of resistivity of silver. See here, as the temperature increases, the metal resistance, length, area, volume go on changes, or that can be increased. Here in the first year you can remember thermal properties of matter. You studied about heat energy in detail. Linear expansion, superficial expansion and cubical expansion. There we studied only about length, area and volume. But remember, as we supplied heat energy, temperature increases. With that, its resistivity or its resistance value also increases. So here we have to calculate temperature coefficient of resistivity of silver. See here, temperature coefficient. That means you can remember in a linear expansion, we used a term coefficient of linear expansion as alpha. Coefficient of superficial expansion as beta. Coefficient of cubical expansion as gamma. Likewise, here this is a temperature coefficient of resistivity of silver. Let us take it as alpha. Here we have to calculate the value of alpha. So first we can write down the givens. Yes, a silver wire has a resistance how much? 2.1 ohm. That is the initial resistance. Let us take initial resistance as R0 and initial temperature as T0. R0 is given 2.1 ohm and initially temperature is 27.5 degree Celsius. As the temperature changes to 100 degree Celsius, so that its resistance value changes from 2.1 to 2.7 ohm. So these are the final values. Let us take R is equal to 2.7 ohm when temperature changes to 100 degree Celsius. Is it clear? So these are the givens. Here we have to calculate temperature coefficient of resistivity of silver. Let us take it as alpha. Yes, we know the equation R equal to R0 1 plus alpha delta T. You can remember this equation. R equal to R0 1 plus alpha delta T. We want alpha value. So let us modify this equation. I can write here R equal to, let us multiply R0 plus R0 alpha delta T, or R minus R0 is equal to R0 alpha delta T, or we can write alpha equal to R minus R0 divided by R0 delta T. So we can use this equation to find the value of alpha. Alpha indicates temperature coefficient of resistivity of silver. Yes, now we can substitute the values. Alpha equal to, what is the value of R? 2.7 ohm minus R0 is 2.1 divided by R0 is 2.1 into delta T. Delta T indicates change in the temperature, T minus T0. So here we can write T is 100 minus T0 is 27.5 degree Celsius. Yes, using a simple calculator, you can solve this problem. 2.7 minus 2.1 is 0.6 divided by 2.1, keep as it is, into 100 minus 27.5 will be 72.5. So alpha equal to, we will get the final answer 0.0039 and its SI unit is per degree Celsius. Or we can write 3.9 into 10 raised to minus 3 per degree Celsius. This is the value of temperature coefficient of resistivity of silver, which is denoted by alpha. Right? Okay, next 8th problem. A heating element using nichrome connected to a 230 volt supply draws an initial current of 3.2 ampere, which settles after a few seconds to a steady value of 2.8 ampere. What is the steady temperature of the heating element if the room temperature is 27 degrees Celsius? Temperature coefficient of resistance of nichrome averaged over temperature range involved is 1.70 into 10 raised to minus 4 per degree Celsius. Yes, see the problem here. A heating element. We are using a nichrome which is connected to a battery which is having power supply 230 volt. Initially, that battery supplies or it gives 3.2 ampere of current. So it settles after a few seconds to a steady value of 2.8 ampere. What is the steady temperature of heating element if the room temperature is 27 degree Celsius? See here, we have to calculate the final temperature. You can read this sentence. What is the steady temperature of the heating element if the room temperature is 27 degree Celsius? Suppose the initially room temperature if it is 27 degrees Celsius, then at what temperature that heating element will be settled down? So we can write the first givens. I am going to write 230 volt. This is potential difference V equal to 230 volt. This is a battery supply. Initially we drawn a current. Let us take it as I1 is 3.2 ampere. Then it changes to I2 2.8 ampere. Initially the temperature is given. Let us take it as T1 27.0 27 degrees Celsius. We have to find its final temperature T2 and the value of alpha is given. Temperature coefficient of resistance of nichrome is given 1.7 into 10 raised to minus 4 per degree Celsius. So these are the givens. We have the equation. In the previous problem we used R equal to R0 1 plus alpha delta T. That equation we can use, but here we don't know the value of R1 and R2, that we have to calculate. Yes, first we can calculate the value of R1 and R2. We know about Ohm's law, V equal to IR. Now I am going to write that equation. R1 is equal to V divided by I1. For R2 we can write V divided by I2. Is it clear? First we have to calculate R1 and R2 value. Then we can easily calculate final temperature. Yes, R1 equal to V divided by I1. V is 230 volt divided by initial electric current is 3.2. Substitute here. 230 over 3.2 will be 71.87 ohm. Similarly, R2 equal to V divided by I2. V is 230 volt divided by 2.8 and that gives the value 82.14 ohm. Now we got the value of R1 and R2. We can use the equation R equal to R0 1 plus alpha delta T, or we can write it as R2 equal to R1 into 1 plus alpha delta T, or I am going to write it as R2 equal to, let us multiply R1 plus R1 alpha delta T, or R2 equal to R1 plus R1 alpha. Delta T is what? T2 minus T1, change in the temperature. Or we can write R2 minus R1. We can take this R1 to LHS side. R2 minus R1 equal to R1 alpha T2 minus T1. So here we can substitute all the values. Yes. What is the equation? I am going to rewrite here. R2 minus R1 equal to R1 alpha T2 minus T1. You can see this equation here. R2 minus R1 equal to R1 alpha T2 minus T1. Yes, now substitute the values. R2 we got 82.14 minus R1 is 71.87 is equal to R1 is 71.87 into alpha value is given 1.7 into 10 raised to minus 4 into T2 minus T1. We don't know T2, keep as it is, minus T1 is given room temperature 27 degree Celsius. Or we can write it as T2 minus 27 is equal to 82.14 minus 71.87 divided by 71.87 into 1.7 into 10 raised to minus 4. Now let us calculate T2 minus 27 is equal to, we will get 10.27 over 71.87 into 1.7 into 10 raised to minus 4. T2 minus 27 is equal to, we will get the answer as 840 degree Celsius, or T2 equal to minus 27, we can take on RHS side, it will become plus 27. So 840 plus 27 will be how much? 867 degree Celsius. This is the final temperature. Is it clear? T2 equal to 867 degree Celsius. Yes, next problem 3.9. Determine the current in each branch of the network shown in the figure 3.30. Yes, here one figure is given. Using that figure we have to find or we have to determine current in each branch of the network. Yes, this is the Wheatstone's bridge or Wheatstone's network, right? Yes. First you have to observe the diagram carefully here. So this is a battery having potential 10 volt. Positive terminal of the battery is connected to resistance having the value 10 ohm. From this battery, let us consider I amount of current is flowing and the terminal A is connected to resistor 10 ohm. Let us divide this I amount of current as I1 for the branch AB, I2 for the branch, let us take it as AD. Then at point B, so here you can observe in the downward direction, directions are already given. Let us take I3 amount of current is flowing through the resistor having the value 5 ohm. Then I2 amount of current plus I3 amount of current together, it is flowing from the direction D to C. In this direction, how much amount of current is flowing? I2 plus I3 amount of current is flowing. Then here at the terminal B, you can observe at point B, here A to B, I1 amount of current is flowing. I3 amount of current is flowing through the resistor 5 ohm. The remaining amount of current is flowing through the resistor 5 ohm. Now we can consider the remaining amount of current I1 minus I3 amount of current is flowing at the branch B to C. Total amount of current is how much? I. I is divided as I1 and I2. I1 minus I3, remaining amount of current is flowing through B to C. I2 plus I3, amount of current is flowing through D to C. Right? So these terminals, let us take it as P and this is Q. Now I am going to apply Kirchhoff loop rule. Here we have to find current in each branch of the network. So we can use the Kirchhoff rules here. We already studied two rules, KCL and KVL. So let us apply those Kirchhoff rules to find current in the each branch. Yes, I am going to apply Kirchhoff's loop rule, Kirchhoff loop rule to the loop. So first I am going to consider the loop. You can observe the diagram A, B, D, A. This is the first loop A, B, D, A. Then second loop we can consider as B, C, D, B. First loop is what? A, B, D, A. So this loop I am going to consider here. Here I am going to apply Kirchhoff loop rule. Then later we can consider another loop, that is BCDB. Yes. Now first we can apply Kirchhoff loop rule here. So from A to B you can observe. A to B. What is the value of resistance? 10 ohm. How much amount of current is flowing? I1 amount of current is flowing. We have the equation V equal to IR. Is it clear? So in place of I, we can write I1. In place of R, we can write 10 ohm. Let us substitute here. I am going to write for the branch A to B, I1 10. Right? Then you have to observe the direction. So I am going to consider the loop ABDA. In the same direction, if the flow of current takes place, then we have to take it as a positive. If the direction is opposite to our loop, then we can take it as negative. Remember this point. So conventions of KVL rule you can remember here. So first branch is A to B. It is along our loop. So 10 I1. B to D it is downward, it is along the loop. So we can take plus. How much amount of current is flowing? I3 amount of current is flowing through the resistor 5 ohm. Then third branch, that is D to A to B, B to D over. Then D to A. D to A is opposite to our loop. We are moving from D to A, but the current is moving in downward direction. It is exactly opposite. When it is opposite to our direction, we can take it as negative minus I2 amount of current is flowing through the resistor 5 ohm is equal to 0. Right? Or we can write it as 10 I1 plus 5 I3 minus 5 I2 is equal to 0. Or easily we can divide this equation by 5. So we will get 2 I1 plus I3 minus I2 is equal to 0. Or I am going to rewrite this equation as 2 I1 minus I2 plus I3 is equal to 0. This is for the first loop. Let us take it as equation 1. Is it clear? Similarly, I am going to apply Kirchhoff loop rule to the loop. Next loop is what? B, C, D, B. Either you can consider BDCB or BCDB, that is left to you. But in which direction you are going to consider the loop? In the same direction the current has to flow, then we have to take it as positive. If it is opposite to our loop, then we have to take it as negative. This point you have to remember. Yes. Let us apply Kirchhoff loop rule. B to C. B to C, you can observe the diagram. The amount of current is flowing is how much? I1 minus I3. Through the resistor 5 ohm. This is along our direction B to C, right? Okay. Then C to D, observe the directions. We are moving from C to D, but the current is moving D to C. So it is opposite direction. Let us take negative. The amount of current flowing is I2 plus I3 through the resistor 10 ohm. C to D over. Then come to D to B. D to B, we are moving from D to B in upward direction, but the current is moving in downward direction. It is exactly opposite. Let us take it as minus. How much amount of current is flowing? I3 amount of current is flowing through the resistor 5 ohm is equal to 0. Or we can write this equation as 5I1 minus 5I3 minus 10I2 minus 10I3 minus 5I3 is equal to 0. Or 5I1 keep as it is minus 10I2 keep as it is minus 5I3 minus 10I3 minus 5I3. So totally minus 20I3 is equal to 0. Or let us divide this equation by 5. So 5 will get cancelled. I1, 5 2s are 10. 2 I2, 5 4s are 24. I3 is equal to 0. Let us take it as equation 2. So these two equations are related to two loops ABDA and BCDB. Is it clear? Then I am going to consider the third loop, that is ADCPQ. What is that? ADCPQ. Observe the diagram carefully. Yes, we are going to apply Kirchhoff loop rule to the loop ADCPQA. Observe this diagram. Here it is. ADCPQA. Or you can take ABCPQA. See here, either you can take ABCPQA or ADCPQA. This loop I am going to consider. Let us apply Kirchhoff loop rule to the loop ADCPQA. Now, A to D you have to observe. A to D, we are moving in the same direction as the current is flowing. Let us take it as positive. I2 amount of current is flowing through the resistor 5 ohm. So we can write I2 5. Right? This is for A to D. Then D to C. Observe D to C. It is also along the direction. Let us take it as positive. I2 plus I3 amount of current is flowing through the resistor 10 ohm. So we can write plus I2 plus I3 amount of current is flowing through the resistor 10 ohm. A to D, D to C. Then C to P, observe. C to P, P to Q, Q to A. C to P. Here the amount of current flowing is how much? I amount of current is flowing through the resistor 10 ohm. Observe C to P, P to Q, Q to A. Observe this part here. Total amount of current is how much? I amount of current is flowing through the resistor 10 ohm. Right? So here I can write it is along the direction plus I amount of current is flowing through the resistor 10 ohm is equal to, here it is having the battery supply, it is having the potential how much? 10 volt. Let us take it as is equal to 10 volt. Is it clear? So now this equation can be written as 5I2 plus 10I2 plus 10I3 plus 10I is equal to 10. Let us divide by 5. I2 plus 2I2 plus 2I3 plus 2I is equal to 2. I2 terms you can observe. So we will get 3I2 plus 2I3 plus 2. In place of I, what to write here? Total amount of current is I and it is divided as I1 and I2 at the terminal A. You can observe this diagram. Total amount of current is I here. So this I is divided as I1 and I2. So in place of I, we can write I1 plus I2. Now let us substitute I1 plus I2 in place of I is equal to 2. Keep as it is. So then we can modify this equation. 3I2 plus 2I3 plus 2I1 plus 2I2 is equal to 2. So 3I2 plus 2I2 will be how much? 5I2. 2I1 keep as it is. Let us write 2I1 plus 5I2 plus 2I3 is equal to 2. Let us take it as equation 3. This is for the loop ADCPQA. Now, using these three equations, we have to find current in each branch. That means we have to find the value of I1, I2 and I3. Using these three equations, let us solve the value of I1, I2 and I3. Right? Now, I am going to use equation 1 and 2. Solve equation 1 and equation 2. Observe equation 1 is here. 2I1 minus I2 plus I3 equal to 0. Equation 2 is I1 minus 2I2 minus 4I3 equal to 0. I am going to write these two equations. See here. 2I1 minus I2 plus I3 equal to 0. This is equation 1. Equation 2 is what? I1 minus 2I2 minus 4I3 is equal to 0. This is equation 2. We have to solve these two equations. So easily here I1 will get cancelled when equation 2 is multiplied by 2 and this is multiplied by 1. So we will get the answer. Observe here I am going to write equation 1 as 2I1 minus I2 plus I3 is equal to 0. Equation 2 is multiplied by 2. So we can write 2I1 minus 2 2s are 4I2 minus 4 into 2 will be 8. I3 is equal to 0. So we can take this is plus minus plus plus. So 2I1 will get cancelled. So we will get 3I2 plus 9I3 equal to 0. So let us take it as equation number 4. We solved equation 1 and 2. Now I am going to solve equation 2 and equation 3. We have to solve equation 2 and 3. Equation 2 is I1 minus 2I2 minus 4I3 is equal to 0. Equation 2. Equation 3 we got 2I1 plus 5I2 plus 2I3 is equal to 2. This is equation 3. So we have to solve these two equations. So here again I1 will get cancelled when equation 2 is multiplied by 2. Equation 3 is multiplied by 1. So we can write this equation as 2I1 minus 4I2 minus 8I3 equal to 0. Equation 3 keep as it is because it is multiplied by 1. So here we can write plus 2I3 is equal to 2. So now we can solve these two equations. Minus, minus, minus. 2I1 will get cancelled. So minus 4 minus 5 will be minus 9I2. Minus 8 minus 2 will be minus 10I3 is equal to, this will be minus 2. Let us take it as equation number 5. So we solved equation 1 and 2, 2 and 3. Now I am going to solve equation 4 and 5. Solve equation 4 and equation 5. Equation 4 is what? 3I2 plus 9I3 equal to 0. Equation 5 is minus 9I2 minus 10I3 equal to minus 2. Right? We have to solve these two equations. So here equation 4, if it is multiplied by 3, 3 3s are 9. So let us take equation 5 is multiplied by 1. So here when it is multiplied by 3 and 1, I am going to write here. Yes. So we will get 9I2 plus 27I3 is equal to 0. Equation 5 is multiplied by 1. So we will get minus 9I2 minus 10I3 is equal to minus 2. So here 9 and minus 9I2 will get cancelled. 27 minus 10 will be 17I3 is equal to minus 2. Keep as it is. Therefore I3 equal to, we will get minus 2 divided by 17 and its SI unit is ampere. We got the value of I3 by solving equation 4 and 5. Now using this value easily we can calculate I1 and I2 value. Is how to calculate I1 and I2 value you can observe. We can substitute the value of I3. Put I3 in equation number 4. I am going to write equation 4 here. 3I2 plus 9I3 is equal to 0. Substitute the value of I3 here. 3I2 plus 9 keep as it is. I3 is how much? Minus 2 by 17 is equal to 0. Or we can write 3I2, 9 2s are 18. That will be minus 18 divided by 17 equal to 0. Or we can take 3 as common here. So I am going to write I2 minus 6, 3 6 are 18 minus 6 by 17 equal to 0, or I2 equal to 6 divided by 17. Now we got the value of I2. Now we want I1 value. So let us put I2, I3 in equation number 1. What is equation 1? 2I1 plus I3 minus I2 is equal to 0. Now let us substitute the values. We will get I1 value. 2I1 keep as it is, plus I3 is how much? Minus 2 by 17 minus I2 6 by 17 is equal to 0, or 2I1 minus 2 by 17 minus 6 by 17 equal to 0, or we can write 2I1 equal to, we can take these two terms on RHS side, it will become 2 by 17 plus 6 by 17. 2I1 equal to, let us take LCM as 17, 6 plus 2 will be 8, or I1 equal to 8 divided by 17 into 2. 17 into 2 will be how much? 34. Sorry, 8 divided by 34, that gives 4 by 17. So therefore I1 equal to how much? 4 divided by 17. So we got a current in each branch as I1 equal to 4 by 17, I2 equal to 6 by 17, and I3 equal to minus 2 divided by 17 ampere. So these are the current in each branch of the network. Or remember, when you got these three equations, first loop ABDA, second loop BCDB, and third loop, that is ADCPQA. When you got these three equations, you are go on solving equation 1 and 2, 2 and 3, 4 and 5 likewise. Or you can use determinants. When you got these three equations, you can go for Cramer's rule. You studied in matrices and determinants in mathematics, you can remember. You can choose these cancellation methods, solving 1 and 2, 2 and 3, 4 and 5, or you can use Cramer's rule in determinants. I will tell you. I am going to use Cramer's rule. In determinants, maybe you studied this rule. Directly you can apply this rule to the three equations from the three loop. So here I am going to write those three equations here. 2I1 minus I2 plus I3 is equal to 0. This is first equation. Second equation, we got I1 minus 2I2 minus 4I3 equal to 0, equation 2. Third equation, 2I1 plus 5I2 plus 2I3 is equal to 2. This is equation 3. So using these three equations, we can easily apply Cramer's rule to find the value of I1, I2 and I3. Yes. So first we have to find the determinant of these three equations. The first point you can remember, let us take it as delta. Delta equal to, the first point is what? We have to find the determinant value. So I am going to write, this is 2 minus 1 plus 1, 1 minus 2 minus 4, 2, 5, 2. So you know how to find the determinant. So plus minus plus. So delta equal to, first we can take 2, 2 into 2 2s are 4 minus 4. So 5 4s are 20, minus into minus will be plus 20. Then minus into minus will be plus 1. Now we can consider these 2 points. 2 1s are 2, minus into minus will be plus, 4 2s are 8. Then plus 1, remaining is 5 1s are 5, minus into minus will be plus, 2 2s are 4. So delta equal to, I can write 2 into 16 plus 1 into 10 plus 1 into 9. So we got determinant as 51. This is the value of determinant. Right? Now we have to find the I1, I2 and I3 value. Let us take it as first delta 1. Delta 1 means I want the value of I1. In place of I1, we have to write the resultant value. So here I am going to write determinant as, now I want the value of I1. So in the place of I1, I am going to write this value 0, 0, 2. Observe here 0, 0, 2 I wrote in place of the first column because I want the value of I1. Remaining is what again? We can write remaining part -1. This is -2. This is 5. 1 -4 2. So in this way how to write? Remaining part is again same determinant plus minus plus. So we will get delta 1 as 0 into anything will be 0, that is -4 plus 20. This is minus into minus will be plus 1, 0 plus 8. Then plus 1 into 0 plus 4. So we got delta 1 as 12. What is the value of delta 1? That is 12. Similarly, we have to find delta 2. Delta 2 means I want the value of I2. So I2 means in place of I2, here the second column, here in place of I2 we have to write this value. So here I am going to write in place of I2 as the first column keep as it is, that is 2, 1, 2 keep as it is. In the second column in place of I2 we have to write the resultant value. So that is I am going to write 0, 0, 2. Then third column again keep as it is. What is the third column? Third column is 1 minus 4, 2. So again find its determinant value. So we will get the value as delta 2 is equal to 18. I am directly going to write the value of delta 2. You can easily calculate delta 2 value. Similarly, delta 3 equal to, how to write the equation? So we want I3 value. So remaining part we can keep as it is 2, 1, 2, minus 1, minus 2, 5 keep as it is. Last column we have to change. So we want I3 value. So I am going to write in place of I3 we have to write 0, 0, 2. So now remaining part is same. Again we can calculate plus minus plus. So we will get the value of I3 as delta 3 equal to, we will get delta 3 equal to minus 6. Yes, delta 1, delta 2, delta 3 value we got. We know delta value also. So here we can use these equations. I1 equal to delta 1 by delta. I2 equal to delta 2 by delta. I3 equal to delta 3 divided by delta. Substitute the value delta 1 by delta. 12 divided by 51. 12 by 51 means we will get 4 by 17. Delta 2 by delta. 18 divided by 51 we got 6 by 17. Similarly, I3 equal to delta 3 divided by delta. Minus 6 divided by 51 we got I3 equal to minus 2 by 17. So either you can use the cancellation method like solving the equations. Go on solving the equation, you will get I1, I2, I3. Or you can use this Cramer's rule to find the value of I1, I2, I3 or current in each branch of the network. The next problem, 10th question. In that there are again 3 sub questions. The first question is, in a meter bridge, the balance point is found to be at 39.5 cm from the end A. When a resistor Y is of 12.5 ohm, determine the resistance of X. Why are the connections between the resistors in a Wheatstone's or meter bridge made of thick copper strips? This is the first question. See here, first we can consider a meter bridge. Is observe here the first question. The balancing point is found to be 39.5 cm. That is 39.5 centimeter is balancing point. That means when we are moving that jockey or the sliding contact on this meter scale, so that if the galvanometer shows 0 deflection, that point we are going to consider as balancing point, and balancing length is given 39.5 centimeter from the point A. Let us take it as A point, and this is B. The question is, when the resistor Y is of 12.5 ohm, determine the resistance of X. Remember, unknown resistance value or unknown wire, unknown resistance is always connected at left gap. Known resistance is connected at right gap. So here Y value is given how much? 12.5 ohm. Balancing length is denoted by L, is given 39.5 centimeter. We don't know unknown resistance X, we have to calculate. This is the first question, that is A. So we know the equation like P by Q equal to L divided by 1 minus L. So in the problem, instead of P and Q, they had given the symbol X and Y. X over Y is equal to L divided by 1 minus L. X equal to Y into L over 1 minus L. So we will get X equal to, in place of Y, we can write 12.5. L value is given 39.5 centimeter, or you can write in terms of meter as 0.395 meter. Substitute here 0.395 divided by 1 minus 0.395. So we will get the final answer as 8.16 ohm. This is the value of unknown resistance which is connected at the left gap, X value. Then in that again one more sub question is given. Why are the connections between the resistors in a Wheatstone or meter bridge made of thick copper strips? Here you can observe this diagram, this red dotted lines that are the L-shaped thick metallic strips. The question is why we have to use this thick metallic strips. So the answer is only to minimize resistance of the connection. To decrease the resistance of the connections, we are using thick metallic strips so that resistance will be decreased. Right? Then, second question. Determine the balancing point of the bridge above if X and Y are interchanged. See here, as X and Y are interchanged, we can write the formula as X by Y equal to L by 1 minus L. We can write Y by X equal to L divided by 1 minus L. Substitute the value. Y value we got 12.5. X value we got 8.16 is equal to L divided by 1 minus L. When X and Y values are interchanged, then what is the value of L? L we have to find. So calculate this value, we will get L equal to 0.605 meter, or we can write L equal to 60.5 centimeter. This is the balancing point when X and Y are interchanged. Then C question. What happens if galvanometer and cell are interchanged at the balancing point of the bridge? Would the galvanometer show any current? See here, when the galvanometer and the cell are interchanged, then we will not get any current through the galvanometer, because remember in the connection at the point D, galvanometer is connected and one end of the galvanometer is connected to jockey. When it is moved on this scale or on the wire, we will get the deflection, we will get the current. Suppose if that cell and if this galvanometer they are interchanged, that indicates no current is flowing through the galvanometer. So this is the 10th problem, right? We can solve remaining problems in the next session.